Okay, campers. So this is going to be not so much a critique, but oh, you academics. So the following is it's just a couple of minutes of Bob and Eric. It is only the portion that I thought was really super easy to follow for what I will call the normies. And that is, the academics always talk about the far end of the conversation. And that was a very PhD worthy conversation with a lot of stuff that some of it I couldn't follow. However, the few things on the end, the diagrams, make it super easy for a visual so you can see exactly what I've been saying about several things. So I'm just going to play the 3 clips and then I will put the things on the end. So I'll go back to I've said this before, there's 3 reasons that economics is off, and Eric is going to display a lot of stuff visually in front of you. And I just want to bring it back to the not PhD level here of they have no unit of 1 because there is no such thing as a dollar, really. Like when you put a dollar on a digital display, it's a problem. That's one problem. That will be displayed. The second problem economics has is they're always coming up with an infinite money supply or a way to print or something of that nature. And they're not really nailed to 3-dimensional space. An infinite money supply causes one problem, and then this ledgerlessness where there really isn't accountability. They're both problems, but they're expressed in the same way. So that's kind of how that has to shake out, is economics has to admit the baseline issues of what they think they're measuring or what they proclaim they're measuring is not even measurable because somebody just prints it into existence and there is no rhyme or technical reason for it. So that whole issue, all of that, yeah, that you wouldn't really even come around to it until you can account for everything with digits and no one could lie and no one could change the precedent, etc., etc., etc. All of the legal reasons. So, and then it's like those 3 reasons, the ledgerlessness, the infinity money supply, or the always ability to print problem, and the lack of unit of 1 in any kind of scientific measure. You can't print kilowatt hours. So, and then the 4th issue is there's always some kind of usury involved. The underpinning of all this is the reason you're going to lend is to get a return. And when you talk about compound interest and simple interest, they're fundamentally 2 different conversations, one of which is moral and one of which is incentive to lend. So when I say the Christians have to get the money and the changers out of the conversation, at least, if you can't see it as a war coin, then you have to at least go simple lending, not compound interest, and you'll know who the decent people who you can trust are, etc., etc. So, without further ado.
If I might, I would love to be able to show you a place where this is visualized. So you see a curve at the bottom of the screen, and that is going to be tracing out a circle. And that's like it's happening in the XY plane. And the height of the curve above it is being depicted in XYZ space. And all of those floating blue squares are these instantaneous notions of constancy that we were discussing before. What Paul Samuelson was saying can't be talked about with economists is the idea that these floating blue planes are in a certain sense incoherent. That means that when you come back, even though you're constantly parallel to the system of blue planes, you don't come back to exactly the same place in the helix above the circle. Those blue squares are like indifference or substitution effects. And so while we are trying to track a change, let's say in ordinal preferences or purchasing patterns, we are locally always constant. But what the path dependence measures is whether or not the system of notions of constancy, the floating blue planes, the distribution, the incoherence, the Penrose steps, all of those concepts that Samuelson were saying you can't really talk to economists about. This is an actual, so far as I know, it's the only visualization of its type in the world. This shows you what gauge theory actually is. It is a series of local notions of constancy that don't knit together. And if you weren't using those local notions of constancy, you wouldn't be doing economics. And it shows you that for that particular path, you better have a gauge that when you come back to exactly the same point in XY space, registers the difference, which is, well, constantly I traded a gum wrapper for a safety pin. I traded a safety pin for a marble. I traded a marble for this. And suddenly now I have a mansion. And the answer is, yeah, you went around a circle and you didn't come back above where you started, even though all you did was make trades. So that is the mathematics that economics has to move to. Or when the Becker-Stigler stuff falls apart, you will have this exhaust on the Death Star, and you don't have a means of staying ordinal.
So, looking at the first graph, you can listen to Eric. I am not here to comment necessarily on anything other than the state of economics and how mathematics has been used against people right in front of their faces, so you can go and correlate the stuff and see it at home for yourself. You don't have to believe. So, that graph, he goes in talking about how the economists are doing the circle math instead of the gasket looking up in the three-dimensional math. You just have to understand the flat math is your price chart math. That dynamic math that he's doing is one price chart across multiple exchanges, like Bitcoin. It gets weird like that. And that's been kind of part of the problem. And the problem is somewhat getting solved, but somewhat not. So, like, to the certain extent, I can only go as far as I know. And what I know is, if you keep looking at the charts, you will see the gaps and you will see the correlations. And you will know that nothing according to price theory and economics goes with the correlations in the market. Trading in Bitcoin should not yield a price movement in anyone else unless there's a bunch of bots that are intentionally arbitraging it, basically bringing it back to that math that Eric is doing. Across different exchanges, you can leverage certain things. So until you can kind of flatten that curve that he's talking about, there's arbitrage across exchanges. Then if you start applying it across coins, you go back to what is price theory. When the whole market is required to some weird extent to go with each other, to move with each other to some weird extent in that short period of time that the math would basically, just get it to the short arbitrageable. We'll call it across 10 minutes. One Bitcoin block. How much arbitrage across exchanges goes on in 10 minutes? How much arbitrage can go across coins on one exchange in 1 minute, in 1 second? So when I say all this math I've been talking about that could be sub-zero because of leverage, you don't even have to think about it sub-zero. You could think about it as not the first 4 digits, okay? This is digital coin clipping that you should be kind of trying to look out for, because the digital coin clipping is an attack vector. And we'll just leave it at that for now. The digital coin clipping is an attack vector, and you got to watch out for that.
You'll see the difference in the two derivatives. And this is without an XY plane. This is a real line, which is in this case T. So there isn't a two-dimensional base space. There's just a one-dimensional base space. And we're going to see that even in this simple example, you'll be able to see how violent a change it is when you become freed from the notion that there is one derivative. So now what you're going to see is $10 an hour, derivative equals 0. And now you're going to see what should be viewed as economically constant. The effect of economically constant is that the levels that you measure the rise over run from have to themselves be economically responsive to the change in prices. So that curve in this new system of horizontal levels is in fact constant. At no point is it rising above the reference levels that you've seen. So let's play that one more time. So to begin with, we see the reference levels. This is the standard notion of constancy from calculus, but somebody's facing hyperinflation. So I would now claim that that function that we're seeing is the right notion of constancy for somebody facing hyperinflation. So now we have a new notion of a derivative just by changing the reference levels, and the rise above reference over the run is now the right economic notion of constant. And what we've just done is gauge theory. That's gauge theory with, you don't need fancy formulas. You can see exactly, there's no attempt to obscure anything. What you're looking at is a powerful tool for recognizing that you have to make sure you're using the right derivative, and that you can't have a marginal revolution in which you just use off-the-shelf derivatives without asking for the right notion of constancy.
Okay, so the second is a very good discussion of what I've been talking about when it comes to the dollar, okay? For those of you who saw that second graph and you believed that you saw the graph curve towards you, did not curve towards you. The graph warped in a mirror effect, north and south. So it started getting wider on the top going north, and it started going wider on the bottom going south. And that is what happens when you square, when you see squared. Okay, if you haven't ever heard what I said about E equals MC squared before, okay, SEESQUARED. When you apply the correct math, you will recognize where the error is. So Eric is showing Bob where the way the economists are measuring it actually warps the graph that they're on. That was the mistake that the physicists were making when they were C squared. You cannot square the second. The second is a unit of measure that you and I standing right here, we have to measure the duration of the away party that is going away from us. And they're going to measure on their side. And the theory is, according to the theory, that the faster they go, that the second will warp. And then there's a discrepancy between their clock and our clock. That's not correct. Okay? The decay rate of cesium determines what a second is. And because the decay rate, all the decay rate, the cesium does not change based on my velocity or yours, ever. Doesn't matter what we're doing. So, because that standard gets warped in exactly the math that Eric is displaying there, if that graph, according to your eyeball, appears to curve towards you, that's not correct. The graph is warped and remained flat. And then I will again warn you, that three-dimensional effect is how multiple exchanges and multiple coins will be passing stuff in between and on that final 4 digits. So, everybody's in dollars, people go from dollars to cents, and then many of the apps will give you the first 4 digits, 3, 4 digits, 2 digits, but they don't give you 8 digits. And very, very few of those coins. Well, they don't give you 8 digits in USD, but they really don't let you measure in Bitcoin and Ethereum like they did back in the day. And recognizing that trading in Gwei is a far, far smaller increment than a Satoshi means that you could, this is exactly how I was figuring this stuff out back in the day, because the stuff was so low in dollars that at some point I found one that was negative just because in the amount of time it was taking me to do the math, I was measuring something that I had to purchase in Gwei. But I pegged my dollar and my Bitcoin to my Satoshi. So I was doing, how much does it cost me out of my pocket right now, United States dollars, to put it into the market in the form of a Bitcoin, move it over to Ethereum, and then buy this other coin with it in Ethereum because I couldn't buy it in Satoshis. And what I found is that for some reason, because you could not purchase those coins in dollars, that the drag between USD, Bitcoin, and Ethereum was yielding such low numbers that I was just like, God damn it, I can't move my money fast enough into this market because I'm pretty sure they'd pay me to take it. So Eric is kind of displaying how these markets will work if they could move in real time in dollars, if the trade pair was available, etc., etc. But it's really just displaying the jungle gym of fuckery that Sam Bankman-Fried and his kind produce when they have an exchange. They sit from a very unique space in a battlefield. It's a financial battlefield, and they have their own exchange. And they're running the computers that it takes and stuff like that. Like I've said it many times before, I was using the Blockfolio app, and that ran off FTX API keys. And when they changed it to the FTX app, I kept using Blockfolio. And I was watching stuff in dollars and Bitcoin and Ethereum. So I kind of really got the rhythm of the night watching this stuff when it was being put together. And then they all moved into the market like the predators they are. And they're just using digital coin clipping. That's really all this is. And, so listen, this is digital coin clipping and packet loss kind of work the same way, especially when you think price theory is what's stitching it all together. So when you get an R bot where your exchange intentionally coin clips everybody at the 4-digit mark and then front runs the trades from the 4-digit mark to the decimal place, okay? That's called winning. You don't have to like it that it's a predator, but if you don't know what it looks like when it's moving right in front of your face and pick your pockets, you're just kind of fucked.
Yep. And also on that one too, just intuitive for people like, oh, the economy's not flat, it's curved. Like
you don't see any curvature there in the sense that we mean curvature technically, because your base space is just time. It's one dimension. It's not until you have two different dimensions. So imagine, for example, we had Cobb-Douglas functions with three goods. Then we'd have an alpha, a beta, and a gamma exponent, and they all have to add up to 1. Gamma is therefore 1 minus alpha minus beta. So it can all be parameterized in terms of alpha and beta. That is already a situation in which you have a sense where Paul Samuelson's floating plane, the distribution, do not knit together. So if you have changing preferences over guns, butter, and carrots, then the sad fact is that you're already in a situation in which going around a loop will have an effect of changing your aggregate level. And if you don't have a Divisius-style index, you will not actually be able to capture the economics. If you do not embrace path dependence, you will wither and die, or you will be forced into lying to the public that you supposedly serve. So in the next example, I want to look at trigonometric functions like sine and cosine. And I want you to ask yourself the question, if you had a periodic function between 0 and 2 pi radians, what would happen if, for example, you were looking at the cosine function and you wanted to only go between 0 and pi rather than 0 and 2 pi, and you were trying to put the function on, at first, a cylinder between 0 and 2 pi, but then on a Mobius band between 0 and pi. Let's roll tape. So there's a sine function, there's a cosine function, and you can obviously see that you should be able to do calculus on a cylinder. But if you try to do it with a sine and a cosine and you put them together, you'll notice that they're not smooth at 0 and pi until you put in a twist. Now the question is there any reason you shouldn't be able to do calculus on this structure? It's smooth everywhere. It's not an XY plane. It's not a familiar place to do calculus. In the same way, cardinal utility functions are like the totality of the Mobius band. Ordinal utility functions are like the circle going through the middle of it. And the Samuelson-Shepard cost function is like these sine functions and cosine functions. So what I'm trying to say is you can get visual intuition pumps for what it is that economics needs to do next, even if this is infinite dimensional, if it's group theoretic, et cetera, et cetera. The basic issues that gauge theory was meant to solve was to allow you to do calculus with bespoke derivatives that are well suited to your problem on spaces that are a good deal more interesting and complicated than the simple spaces like the XY plane, the XYZ space, and more intricate than simple functions, because these things are more derived from the graphs of functions than maps from a set A to a set B. So in all of three of these cases, we're trying to say that Samuelson was correct, but you can actually use visual aids for economists to realize you guys are in the best situation you could possibly be in. Everything that you do is gauge theoretic. You just don't know it yet.
Okay. And just in case you needed a visual on how you can stitch two price charts together in vector space, it cannot be made any more obvious to you that you run a Fourier series just like a needle and thread through a bunch of math that Eric just displayed and showed you. It's just a twist in the vector space, and you're suddenly in a different plane. Just that quick. Just that quick. All of the most beautiful pictures to describe digital fuckery in the market and what that predator looks like, because everybody got told stable coins, because the least stable thing on earth is the distance between 0 and 1 measured in United States dollars. That's the entire discussion of inflation, deflation, stagflation, fucking money printing, everything you've ever... Listen, witchcraft comes out of the Potemkin village. When you got enough cash to create a Potemkin village because you're a dude with a printing press. And eventually the game, like, if you think the jig is up, what happened? When the mystery buyers showed up to buy U.S. government debt? Mystery buyers, everyone. Wow. And lo and behold, we find out later, what are they? They're stablecoin companies. They wanted to buy, they had to, air quotes, legitimize U.S. debt. Oh, I'm sorry. They had to legitimize the cryptocurrency space by buying U.S. debt, right? Right? So when I say the fuckery is still going on in dollars, the cleanup is basically going to have to get done in dollars. So because the people who bought the U.S. debt are no longer, like the stablecoin companies are now vested in the debt pool. So now it's moving, it's, it goes back to kilowatt hours at some point. At some point. When? I don't know. Because the Chinese apparently were running a numbers game with their population. They were able to justify greater amounts of money printing because they basically added somewhere between a third and half to their population size. So they're probably not over 1 billion, but their government was able to justify the printing of more than 1 billion. Well, liquidity. Liquidity. So this is how the digital fuckery works, and it is getting cleaned up. Like, that's where I'm kind of hopeful. Why? Because it's the reason I'm not panicked is because it would only take a software update at every terminal, and boom, we can move to just dollar plus crypto. The end. The end. And nobody would have to ask what a stablecoin is again, because everything would go immediately to $1, and everybody who just got one would be happy because now you could spend them at a store. And it would create money velocity on a different network in the same increment that is non-incremental, so that somebody could probably print it for another year. I don't know. But the level of fuckery that will go on so that the dollar doesn't have to suffer competition. We're running out of places here on Earth to sell the story that is anything other than war and that which it perpetuates. And so this is Sith Master level of digital fuckery. Please guard your wallet accordingly. Have a Merry Christmas, campers, and Merry Christmas, Velma, wherever you are.